first lecture we have derived del square es minus gamma square es vector is equal to 0, or del square minus gamma square es vector is equal to 0, where es vector is the electric field component. Now consider wave is propagating in positive z direction. For positive z direction, z direction means plus az cap, and es has only x component. Then we may write the value of es vector. Es vector is equal to E excess z ax cap. Here ax cap is the direction of electric field, and this denotes propagation. This is the propagation direction, and this is the direction of E vector. Okay. E vector direction. S denotes phasor form. Now we can write del square ex s z upon del z square minus gamma square ex s z is equal to 0. Here del square is nothing but del square, but it is differentiated only in the direction of z, because here propagation direction is z. So del square upon del x square and del x square upon del y square components are not written here. So del square upon del z square minus gamma square bracket exs z is equal to 0, and now we can solve. Let del upon del z is equal to m, so m square minus gamma square is equal to 0, and we get m is equal to plus minus gamma. Here two values are calculated of m. So ex s z is equal to e naught e की power minus gamma z plus e naught dash e की power plus gamma z. So two components are there because it is applicable for positive direction or negative direction. This component show positive z direction component, and this is shows, and it shows minus z direction component. Okay, and gamma is propagation constant, because it is finite for positive z values. If it is negative, then e to the power infinity, e to the power infinity is infinity. So this is possible, this is finite for positive z direction, positive z values, and it is finite for negative z values only. That's why minus sign shows positive z direction and positive z direction shows minus z. Okay. Now we can write electric field component with time factor. So finally EZT is equal to real value of EXS Z into e to the power j omega t, where e to the power j omega t is time factor e to the power j omega. Now I am considering positive z direction. So, the value of Exz is E naught e की power minus gamma z into e to the power j omega t ax cap. We know alpha is equal to j alpha. We know gamma is equal to alpha plus j beta. So put the values of gamma and we get EZT is equal to E naught e to the power minus gamma z e to the power j omega t ex. Real value, and it is equal to E naught e to the power minus alpha z cos omega t minus beta z into ex. Here, it shows propagation direction, and it shows it is positive or negative. If this is negative, then positive direction. So here direction is z. So I have written positive z direction. Alpha is attenuation constant. Omega is the frequency in radian per second. Now, what is intrinsic impedance? What is intrinsic impedance? Intrinsic impedance is denoted by eta, and it is the ratio of electric component to the magnetic component. Okay, we know del cross Es is equal to minus j omega mu Hs. This is the Maxwell equation number 3. Now, Es vector is equal to E naught e to the power minus gamma z into Ax. Okay, actually it is written Exs, so we can write Es also. Now this equation gives Ax cap, Ay cap, Az cap, del upon del x, del upon del y, del upon del z, E naught e to the power minus gamma z 0 0 is equal to minus j omega mu Hs vector. So it is equal to minus Ay cap minus del upon del z E naught e to the power minus gamma z is equal to minus j omega mu h naught e to the power minus gamma z into Ay cap. Because we know pointing vector is equal to E cross H. If the direction of propagation is Az cap, direction of electric field is Ax cap, it is obvious that H vector is in Ay direction. That's why Hs vector is written H naught e to the power minus gamma z into Ay cap. Okay, so this is the fundamental. Now we can see after comparison we get E naught gamma is equal to j omega mu h naught. We get intrinsic impedance eta is equal to E naught upon h naught is equal to j omega mu upon gamma. Gamma is j omega mu into sigma plus j omega epsilon. It is equal to eta is equal to under root j omega mu upon sigma plus j omega epsilon. Okay. So what is the value of magnitude of eta? So it will be equal to an angle of eta of